So let's look at the natural log. Again, look at your calculator. You see a button called what? ln. That's the natural log. And what does that mean? What's the base?
Whatever you want it to be?
No. Good try. Log base what? What do you think? E. You know what E is? E is like pi. 2.71828. Very popular in science, very popular in engineering, finance. The natural log is actually more common in finance and engineering than the common log. We use that all the time. So when you see the natural log, it's really log base E. So if we ask you, and again, E is 2.718. If I say, can you tell me what's the natural log of 2.718? The answer should be almost 1. Let's test it. 2.718, hit ln, 0.999998, which is a 1. What's the natural log of 3.9? Notice I'm giving you the number, I'm looking for the answer. What's the natural log of 14.6? What's the natural log of 0.015? What's the natural log of 31.9? I'm giving you numbers here, I'm looking for the answer. In that case, just like the common log, it's straightforward. You go to your calculator and type that number, 3.9, and hit the natural log. 1.36. The next one, I go 14.6. Give me the natural log. 2.68, 1. The next one, 0.015, hit the natural log. That's negative 4.199. Well, actually, 4.20. 31.9, hit the natural log. 3.463. Remember again, I said earlier that the graph of the log, it doesn't matter if it's the natural log or common log or log to any base. It's this one. So if your number is more than 1, the result is positive. If it's less than 1, between 1 and 0, the result is negative. This number between 0 and 1, the result is negative. The rest of them are more than 1, the result is what? Positive. What's the natural log of 1?
0.
Let it be 0 from the picture. Doesn't matter what the base is. What's the natural log of 0?
Error.
Error. Can't be done. What's the natural log of a negative number? Error. Going back to the rules, you can only take the log of a number that's greater than 0. So the natural log, you give me a number, I'll tell you what the answer to it. What about backward? If I give you the answer and I ask for the number. So like these examples. If I said the natural log of some number equals 5, not 15. 15 will be huge. Or the natural log of y minus 1 equals 4. The natural log of 2x minus 1 equals 0.2. Can you solve for x? Can you solve for y? Can you solve for x here? Since I'm giving you the answer here, I have to use the key directly, the opposite to the natural log, which is actually the inverse. Let's look at the key directly over the natural log. What do you see? E to the x. So if you want to find x here, That's going to be e to the 5. So go to your calculator. Here we go. 5 e to the 5. Oh, I screwed up. Let me try it again. 5 e to the 5. Did you get 148.4? This one, I used to call the number. The number is actually y minus 1 has to be what? E to the 4. This whole thing has to be e to the 4. So what's e to the 4? So y minus 1 is 54.6. Can I solve for y? What's y equal to?
53.6?
How about 55? You add 1, right?
Yeah, 55.
You have 55.6. Because to solve for y, you got to add 1 to both sides. What about this one? You want 2x minus 1 has to equal what? E to the, to what?
0.2.
0.2. Good. E to the 0.2, that's 1.22. Add 1 to both sides. 2.22. To solve for x, you divide by what? By 2? Now, in case you're wondering why they cancel each other, why is it e to the x, just like with the log? Why is it 10 to the x? I'll give you the answer, which is rule number 3, actually. Remember rule number 3? It says if you have log y base b equals a number, then, or x, I think I used x, right, for that rule? I think I used x when we did it. We said that's equal, you can go back and forth to what? Y equals b to the x. Well, apply that rule. You can apply it to both the previous section and this one. When we said to you, can you tell me what the answer to this? Use that rule. It says x, which is the number here, has to equal to what? The base. Well, what's the base? If it's not here, it's what? 10 to what power? 2. That's why when you look at that button, actually, 10 to the power. The same thing with the natural log. When I ask you, why is the answer to this e to the 5th? The natural log of x equals 5. You want to solve it. Well, the natural log is log base what? Yep, that's log base e of x equals 5. Apply that rule now. That says what? X has to be what? E to the power of 5. So I'm actually using rule number 3 to find these. But I don't have to add that step to get to this. I can get to it in one step going, if I have the answer, I'm looking for x, just do e to the power. But that's what the result came from this step here. So if I have log t minus 2 equals 3. That means t minus 2 will have to be what? Using that rule.
10 to the third?
10 to the third, exactly. What's 10 to the third? 1,000. Add 2 to both sides. What's t equal to? 1,002. When you have the answer, you're looking for the number, it's 10 to the power. So it goes back to rule this one. But here's the problem. It's going to be facing us, all of us. I come in and says, good, you got it. We're almost done with this section. Can you tell me, now some of you might have a calculator that does that, mine doesn't. Can you tell me what log 25 base 7 is? Now I got a problem. My calculator does not do that. I only have log base 10 and log base E. Not log base 7, not log base 3. I can still do it actually with this calculator, with this cheap one. It's called the change of base. And that is, I'm going to derive it y actually. I'm going to show you why it is. Let's call the answer x. Because I just don't want you to see it go, well, he said that, Z said that. I want you to see why is it. Let's use rule number 3. Let's change it to what? Change it to exponential. So that would be what? 25 equals what? 7 to the x. 7 to what power is 25? Your guess is good, mine. No clue.
X is equal to?
Can't be 2. 7 squared is 49. Right? So it's way less than 2. Between 1 and 2. 7 to the 1 is 7. 7 to the 2 is 49. Well, since I got a calculator handy, that's an equation, right?
It's 3.5.
Can't be 3 points. It's between 1 and 2.
1.6541741.
Maybe. Maybe. You have a calculator that does that? So I'm going to show you. He does not have an advantage over you. Don't worry. He won't have that. This is an equation. Whatever I do to one side, I got to do the same thing to the other side. So since my calculator has the log or the natural log, let's pick one of them. Which one? You choose it.
Common log.
Common log. Okay. Let me take the log of both sides. Right? If you take the log of this side, you got to take the log of that side. So, rule number 6. Remember what rule number 6 was? If you have a power, what can you do with it? Put it in the front. Now, I can't tell you why I write log capital and log small here. I don't know why. I'm just moody. Depends whatever I write there. Can I solve for x now?
Mm-hmm.
How?
Dividing on one side, the log side, and then on the other.
So let's try the calculator and see if we get the same answer you got. Log of 25. 25 log divided by 7 log and hit the equal sign. I got 1.654174951. Is that what you got?
Mm-hmm.
Yep. And by the way, I said pick a log or the natural log. Curiosity is bugging me. Could also x be, could it be the natural log of 25 over the natural log of 7? Would that give me the same answer? Let's try it. Is it 1.654174951? Same exact answer. So we can find the log of any number to any base. So here's the rule for that. It's called the change of base rule. I want you to see where it came from, the math behind it. If we ask you for log n base b, any base, you can find that by taking the natural log of n divided by the natural log of b or the common log of n over the common log of b. Either way. So if I said to you, can you tell me what is log 27 base 4? You go, sure. That's the natural log of 27 over the natural log of 4, or the log of 27 over the log of 4. Let me know if, because my calculator is acting funny, I have to hit the button sometimes 3-4 times. Did you get 2.377?
Yeah.
Yep. What's the log of 19 base 11? Again, I'm picking some numbers. I know they're not going to be there. And let's see what the answer is. .228. Is that what you got? So that's how we find the log of any number to any base. Now you might be saying, why are we interested in the common log or the natural log? Well, we need to know them for the last section. That would take us about an hour, actually. So let me